Hope you enjoyed the last week discussion, what we discussed the last week. Um, okay, get ready. Are you ready? Can we start the class? Okay, fine. So this week we'll be focusing on descriptive statistics. Of course, we have completed the last week data, various types of data, and the flow that we follow in data analysis. Now, this week, we'll be moving to the next descriptive statistics, where we'll be learning the different things we do, different analysis or different calculations that we are doing to understand the data. Okay, so this week we'll be focusing on mean, median, mode, variance, standard deviation. These are the basic things we do when we have a large data. And in addition, we'll be learning few tests, statistical tests. Okay, so this is the learning approach, the flow that we are going to follow for the next 90 minutes. You'll be understanding the terms, various terms, and you will learn the concepts. And I will show you some examples, explain you how the terms, these terms are to be calculated manually and using some simulation tool. It could be Excel or Python. And you will have some exercise for you to practice at home. Um, so with this one, let me start this week class. All good. Okay. In the last week itself, we understand that the data is around us everywhere. All right. So the data can be of in the form of numbers or categorical. All good. So when we want to do some analysis, data analysis, what we do is we collect the data from different locations of different spaces. Okay, spatial locations are maybe it could be uh, of timestamps, temporal data. However, the data what we will be having will be a large data set. And whatever the observations, possible observations we have in the data set are called population. So population is the set of all possible observations. All right. So what we do is we just do some analysis on the population, right? But sometimes it may not be able to do the analysis on population data because of its big, large, okay, huge amount of data that we have in our data set. So what we do is we can sample our data. We can sample our data in the sense we can choose few data of populated data. For example, you look at the example over here in 2014, it was about 834 million people are eligible to vote in the Indian general elections. In the sense, when you want to do the analysis with 834 million, it will be very cost effective, very costly, and the time will be very high, and you need more computation technology, or the hardware or software, whatever it is. So you need such things to handle this kind of large data, 834 million of data. So what do? We choose the data from 834 million. Maybe we can count, we can consider only thousands of data or 10,000s of data. Okay, so in this sense, we are going to have samples out of 834 million data. So sample is a subset of population. Okay, population is a universal set. It's the complete. And we have some rules to follow when we take samples. For example, we will not be focusing on a particular area of populated data. We consider different parts of your populated data. So there are some mathematical rules as well. Okay. However, what we do is we just collect the samples and then start doing some analysis with the samples. Sometimes what we do is we will take different samples, right? In the sense we take groups from different parts of population, okay, and we do analysis, okay, take test on each samples, and then we may compare the variance between the samples. So this is also, yeah, one of the ways we can do analysis. Okay, fine. So I'm just showing an example over here. It is of daily sales revenue. And of course, I have 7 data over here. And in case when you want to do some analysis on this data, before taking up the calculations, please you ask some questions yourself, like which sales value looks typical? Is there one repeated value or many repeated value? Or the sales values close together or spread out? Spread out in the sense, is there any outlier? So you should ask some questions yourself before start calculating or before going to do some actions or some computations. Why? In the sense, all your test is based on the questions that you have. So we work for the questions. We do some calculations or we do some testing only based on the questions. So please, you make your questions ready fast before you go for calculations. All right. Coming to the terms that we are going to discuss today, and of course, it's of central tendency. I'll be focusing on finding the center and the spread. Okay. These are the two different things I would like to discuss with you in this week. Okay. Mean is the one of the important terms we consider in our data analysis, in our test. Okay. Mean is an average. Okay. Is an average. Is the total of values divided by number of values. So in this is the formula that we are going to use, sigma x over n. So all what you need to do is, in case if you have the data or something like this, so just add them together. You just add all values and then divide it by number of values, count. Okay, 1, 2, 3, 4, 5, 6, 7, 7 count there. So number of total amount over 7 will give you the average or mean of this data set. Here, when you are this mean we work with only numbers. Okay, continuous numbers or whole number, but it is not related to categorical data. Okay, this is the one important thing you should note down. And we have functions over here. Maybe if you want to do this, if you want to find mean using an Excel, maybe you can use average function. So average is the function in Excel to find out the mean or average of numbers. And if you are using Python interpreter, you can use statistics library. You can import statistics library and can use the function called mean in statistics library to get the mean of your numbers. And in case if you want to find out the count number of values in the data set, you can use count function in Excel. Okay, all good. So you may be working with the population data or sample data, right? So if the population sample is considered, this is the formula. This is the formula for sample data. The only difference I should mention here is that the notation that you are using. Like mu is the notation we use to define mean for population data. This is population mean. X bar is the one we use for sample. Okay, sample mean. So rest is everything same. The formula is similar. Only thing is we use either mu or X bar. Depends on population or sample. Okay, so the formulas over here. Right. The next term I would like to introduce to you is median. Median is the one representing the mid of your data set. Mid of your data set. So what you need to do is just sort out all your numbers, arrange them in ascending order or descending order. Okay, once you arrange them in the order, ascending order, then you can locate the mid value or mid of your data set using a function called median. Median is the function we use in Excel. Rather, you can use median function in statistics library as well if you are working with Python. All right. But the thing is, sometimes we'll be having odd number of values, or sometimes we have even number of values. So you will find the mid value based on the count. In case if you have odd numbers like this, the one I'm showing here, 7 numbers over there. So what you can do is you can easily look at the mid value 61, leaving 3 values on left, 3 values on right. So this is perfectly okay if it is odd. In case if it is even number, what you do is you will consider the two numbers, okay, the two mid values and take the average. For instance, I tell you, in case if you have another number here, okay, another number here, 80, okay, another number. So in the sense we have 8 numbers here. So what we do is we consider the fourth number and fifth number and then take the average of them. 61 plus 70 over 2 will give you the median value. That's your answer. Okay. So median numbers, median is the term we use, we work with numbers. Okay, all good. So I'll move on to the next. So this is the formula showing how to find the median value if it is odd number of values there, or if there are even numbers. And the function over here in Excel and the function in Python. All good. Next term I would like to introduce to you is mode. Mode is the one we use for the categorical data mostly. Okay, so that in the sense what we do is we will try to find out the one appearing most of the time or frequently appearing value. We are trying to find out the values that appears most often. Okay, that is what called mode. So all you need to do is you need to find out the frequency of the values after you may, it's better to arrange them easier. That is better arrange them first. Even if you don't arrange, it doesn't matter. But all you need to do is you need to find out the frequency of each number, each value. For instance, if you look at this data set, 42 appears 1. Actually, you look at here, the 42 appears once, 55 appears 1, 61 appears 2 times, 70 appears 1, 72 appears 1, 85 appears 1, 80 appears 1. So that's if want to find mode, you just find the frequency of each number and you just choose the number that appears most frequently. So for our case, it is 61. 61 is the median mode of the given data set. Okay. Sometimes we may be having two numbers appearing in the equal number of times. Okay, sometimes, or three numbers appear equal number of times. So it will be multiple modes. So we may be having multiple modes. So what you can do is in Excel, you can use this function if there is only one mode appears in your data set. You can use the next one, the mode.mult. This function you can use if you have multiple modes in your data set. Okay. Same way in Python, you can use statistics.mode to find out the mode of your data set, or if it is single, or if it is multi-mode, you can use multi-mode function in Python. All good. So mode formula is the same thing. Okay, same thing for both cases. For numbers and categorical data, everything same. But all you need to do is just you see how many times the data appearing in your data set. It's a counting. All good. So I just summarize here mean, median, mode. Which one I should use in my data analysis? Okay, so this is very much important for you to take or choose the right term, uh, right method for your analysis. Okay, when you are working with the numerical data, you can use mean or median. But see that if you are using skewed data or outlier data, better you go with median. So what I try to say here is, you just look at the sample over here on the bottom. Okay, you have 3,000, 3,200, 3,500, 3,700, and 20,000. It's a big number. The sense, if you want to find the mean of this number, it won't be in the range of 3,000. So it will be something higher than 3,700, something somewhere else. So that means it is pulled up, it pulls up the mean value to somewhere else. This value, this is the value, higher value called outlier value. This outlier value will pull up the mean. So when the mean is pulled up, so your decision may be, or your test result won't be right. So what you need to do is, for this kind of cases, better you go with median. Median will give you the mid value, which you can use. Maybe it could be 3,500. Okay, for your case, it is 3,500. So easier, much easier to work with. And if you are working with the categorical data, then you go with mode. Okay. And then another example, salary data with very high earners. High earners in the sense you have the outlier, skewed data. So better you go with median. Customer segment or region. So it is based on the categorical data. Region in the sense you go with mode. All right. I have a question for you. Please, you go through this question and answer to me. For customer satisfaction ratings from 1 to 5, which measures would you report and why? Customer satisfaction ratings from 1 to 5. You must look at the data that you have. Your data is 1 to 5. Right? It's an ordinal number. So you are working with ordinal number. So then, if that's the case, what would be the right term that we need to use in our, or that we need to include in our calculations? One is median, because you are working with the ordinal number. So better to have the mid value for your interpretation. Another is mode. You may be interested to see the frequency of that particular satisfaction rate appearing in your data set. Okay, so for this case, we don't use mean. Okay, this case we don't use mean, we use only median or mode. And you may include interquartile range, IQR. But of course, I haven't included IQR in my slides. I'm not going to teach you, but I'll give you a brief introduction of IQR. IQR is the best way to identify the skewness. What we do is, in the IQR, we divide the data set into 4 equal parts. So we will be having Q1, Q2, Q3, Q4. So you can find the difference between Q3 and Q1, and can identify the spread of your data, or the range, how the data is spreaded out. So that is what called IQR. So either what you can do is, for this case, the satisfaction rating case, you work with median, mode, or IQR. Okay. So I just put here the explanations why we need to use these measures, and why not mean? Because mean is not good to use in this example, because We are not focusing on any average, or we don't want to find the average to interpret our data. Our focus is to know how many customers have given higher satisfaction rating, or how many customers have given the satisfaction rating within 4 and 5. So these are the few things we would like to interpret from our data. So for this case, it is not good to go with mean. So if you go with median and mode, you can write like this, like you can say 42 plus 25. It is about 67% of the customers are satisfied with our product because they rated our product in the range of 4 and 5. So we can say 67% of customers are happy with our product, and you can say 20% of the people are satisfied because it is the mid value, you understand. So you can say that most of the people are 20 percentage percentage of the people are in the mid of the satisfaction rating. Like this you can interpret. Okay, so this is the way we work with the mean, mode, and median. Fine. The next term I would like to introduce to you is variance. Variance is a very important thing. We work with data analysis. We work in our data analysis. For example, what we try to do here is um, we we have mean value. For example, okay, we have mean value. It is x bar, and our data may be somewhere else. We are not sure where the data is, somewhere else. We try to find out the distance between each data and mid or mean value. So we try to find out the distances between them. For example, this is D1, this is D2, this is D3, this is D4, and D5, D6. So for example, I'm finding the distances for 6 different data. The difference between the mean and the actual data. So after finding this difference, you can square them out, okay, and dividing it by number of values will give you the variance. So variance is the one measure that we use in our calculations or our analysis to understand the spread of the data from the mean. Spread of the data from the mean. So usually any company, what they do is they find X bar and see that their quality is spreaded out within some sigma, maybe 3 sigma. Okay. So what we do is we use the standard deviation. After finding the standard deviation, we can fix our quality control like 3 sigma on right minus 3 sigma on the left. So whatever the quality of your product within this range is acceptable product. If the product has the measurement beyond this range, somewhere here we don't accept. So this is how the quality control is done in any company. Okay. So mean is one of the important terms or measures we use in our data analysis. All you need to do is you need to find the mean of your data. After finding mean of your data, you just find the difference between mean and the actual data, that is the distance, then square the distance and take the average of squared distance. That will give you the variance of your data. So in case if you want to do this action in Excel, just use VAR function. VAR function VAR dot S is used for sample data. VAR dot P is used for population data. So you can use either one. In the same way, in Python, you can use statistics dot variance or statistics.p variance. P variance is referring to population variance. This is referring to sample variance. So you can use either of these functions to find um, variance of your data. So this is mathematically very much important because you are squaring the distance. Okay. Whereas to explain our variance to the company or management or senior management, it is better to go with standard deviation rather than variance. Okay. So I'm showing the formula over here, the variance formula. For population variance, we use sigma x minus mu squared divided by n. Whereas for the sample variance, we use sigma x minus x bar squared over n minus 1. So that's the difference you should note down, because this difference n minus 1, here we use n, capital N, which refers to count number of values. Small n is the one we use for sample data, counting is there. So x bar is the one we use for sample, mu is the one we use for population. I told you already. Okay, so the formula here is x minus x bar square over n. Okay, n. So when you use this formula, so there could be the chance to have underestimation. So to correct this one, what we do is when we are handling with the sample data, we use n minus 1. So this is the actual formula for finding variance, sample variance, n minus 1. This n minus 1, the correction is called Bessel correction. It is an idea given by this researcher, Bessel. So that gives us the exact sample variance. Okay. So you can use this formula to find variance, and what you can do is, if you take the square root of variance, that will give you standard deviation. So standard deviation is the best one to explain to your management. Okay, it is the measure spread in the original unit of the data. All right. So what you can do is, in Excel, you can use this function stdev.es for the sample standard deviation, stdev.p for the population standard deviation. Same way, in Python, you can use statistics.stdev or statistics.pstdev. So these are functions, two functions in Python to work with the standard deviation. All good. Coming to the interpretation, if you have low standard deviation, your values are very close to the mean. That means all the values are plotted very close to each other. Okay, so if this is your x bar, if you have the values very close to the mean, then it will result you very low standard deviation, sigma value. If the values are far away from your mean, ultimately this sigma value will be higher. So if you are thinking of your quality control, so you know the quality that you want to maintain, mean value, you know, and when you are measuring the quality of each product and see that it is very close to X bar, you can say that reliability there. It's a standard reliability over there. So that is how you can interpret your result. All good. The formula for standard deviation is very similar to variance, except root of. You just to do, you take root of variance. That will give you the standard deviation. All good. So I'm just listing here the functions we use in Excel as well as in Python. So you can use these functions later. And I'm just showing here various terms that we are using for population and sample. Okay, I explained you already, capital N, small n, mu, x bar, all these things. So these are the things over there. Just a quick recap. Mean gives you average. What is the average? Median gives you Where is the mid value? Mode gives you which occurs most often. Variance gives you how spread out values. Standard deviation giving you typical distance from the mean. So you are taking a typical distance from the mean for the whole sample data. Right. Coming to center and spread. Okay, I just put the formula over here again, once again for you to practice. And the takeaway is the same thing what I told you earlier. Just I put one more slide for you to go through it. Okay, but for the good descriptive statistics, okay, for the best decision making, you have to consider first the question, research question, and you have to choose the right terms that you need to work with, and then only you go for the interpretation. All right. So good descriptive statistics help manager to make better decisions from the data set. So I have a homework for you. Maybe what you can do is you just collect the data from your own mobile phone, the WhatsApp messages that you sent to your friends in last 30 days. You create an Excel with that data, your own data. Okay. So friend X, friend Y, friend Z. Okay. How many messages you sent in last 30 days? You just list them. You make a Excel sheet with that one. And then you can use the functions for mean, median, mode, variance, standard deviation, all this. Okay. So these functions you can use, and you can see how frequent you send a message to a particular person, and what is the average number of messages that you are sending in 30 days of time. Like this, you can, or a week of time. If you are considering a sample data, 30 days data is a population data. You can consider 7 days data as a sample data and can find out average messages that you send to your friends in 7 days of time. And you can understand when did you send the message, in the first week or third week or fourth week, which week is the most number of messages sent. So you can analyze your own data with this one. So it's a home task that I am giving to you. You can practice in Excel or in Python. So I'm giving here the Python codes for you. Okay, in case if you want, you can use it. Next, Vishal, I have few questions for you to choose the right measure. Okay, let's read the question, and you tell me what measure you would like to use for this scenario. The first one, a company wants to report the typical salary of employees. Company wants to report typical salary of employees, but few employees, few executives earn very high salaries. What would be the right measure you will report? So coming to this question, your work task is based on salary numbers. Perfect. But you see that there are some employees getting high salary. So when you use the high salary data in your analysis, in your calculations, ultimately it is going to be outlier, going to be the mean value going to be pulled off from the actual value. So what you can do, it is better to use with median. Okay, so for the first question, better you use with median, because median is the mid value. It is strongly affected by a few extreme high values. Mean can be pulled upward by executive salaries and may not represent the typical salary of employees. Okay, I give here some example where you can notice the higher one, 300K, is included in small values. So ultimately, this pulls up the mean to 84K. When you consider except 300, all other values, it should be within this range, 50 something. But when you include this 300, it is going to be $84, 84K. So ultimately, it is misleading your analysis. So don't use mean, instead use median. All good. So I go back to the next question. A manager wants to know the most common product defect. Which measure should be used? The manager wants to know most common product defect. That means the defect appears over the period of time. Okay. So the defect may be the first day defects may be 100, second day defects may be 10, third day defects may be 20. We do not know. It appears in every day. So you want to find out the most appearing defects, most occurring defects. That means your intention is to find the frequency of the defects. Okay. So best thing to use here is mode. So mode is the categorical data that occurs most frequently. For defects types, mode identifies the most common defect appearing in or over the period of time. Okay, so this it's a measure that you can include in your analysis, and you can write a interpretation, or you can give a suggestion to your management, so that management can take control action against the most affected defect or most appeared defect. Okay, so managerial action will be focus quality improvement efforts on reducing scratching defects first. Okay, for this question I put here scratching 12 times appearing, discoloration 8 times, crack 5 times, incorrect size 3 times. So I know that the scratching appears more frequently, so I should take the decision to reduce the scratching. So the management can take a control action against scratching based on your interpretation. So for this question, it is better to go with mode. Okay, coming to the third question, a manager compares two branches with the same mean sale. So the sale in two branches are compared with, but one branch has large standard deviation. What does this mean? So you have two branches. One branch, both branch have mean sales. Okay, for example, 100K, 100K, same sale wise, there is no change at all. But when you see the standard deviation, one has low, other one has large. So if that's the case, what would be the right measure you or what would be the right suggestion or action you will do? So when seeing the variance or the standard deviation between the branches, the lower standard deviation is better one to have. When it is larger, we know that the data are not uniform, not consistent. Okay, in the sense that the sales data over there in that particular branch is spreaded out, not uniformly distributed. So you can suggest to your management that it is not reliable. That particular branch is not reliable. So that particular branch has less consistent sales. Okay, so large fluctuations over there. When the large fluctuations, it is high risk. Okay, so the conclusion is small standard deviation is reliable. So you can consider that branch is okay, good. Whereas for the large standard deviation branch, you have to take some action to bring it down. Okay. Going to the next question, a delivery performance dataset has one extreme delay of 180 minutes. So there is a delivery performance. Okay, we have the data of delivery performance, but one extreme delay is there. It is about 180 minutes. Now, what measures that we use for the interpretation, for the suggestion? Should we use mean or median or both? What do we do? Actually, this is number. 180 minutes is the delay is number. Okay, it could be 30 minutes or 40 minutes or 60 minutes, or doesn't matter, but numbers. So you can work with mean and median, both is okay. But see that one particular day it is 180 minutes. That means it is exceeding. It's outlier. So that case median is better to represent. So you can use either mean or median. Okay, both okay. You can report median, mean and median, and you can write like this. The mean shows overall impact of extreme day. Okay, the median shows the typical delivery experience, right? For example, you can write the suggestion like this. The median delivery delay was 16.5 minutes, while the mean was 31.5 minutes. So this difference is caused by the extreme 180 minutes day. Okay, because if you don't consider this 180, the rest everything is okay. The mean and median would be close to each other. But because of this 180 minutes is included in the data set, ultimately it has pulled the mean to 31.5 minutes. It is higher. So there is a big difference between them. So you can write like this. Because of this, on seeing the difference, huge difference between mean and median, we understand that there is one extreme delay there. That is the one causing this difference. Okay, going to the next question, the last question. Create your own workplace data set with at least 10 values and write a short descriptive summary. It is purely your own descriptive summary you are writing. So you can create a data set with the 10 values, okay, any 10 values, and can do these calculate these measures, and then write the descriptive summary of your own. So I give here an example how to write it. So I just put here, yeah, daily calls handled by one employee over 12 working days. The employee attends 42 calls on the first day, 40 calls on the last day, 12th day. So I have calls attended by that employee in over the period of 12 days. Okay, so data set is 12 values. Perfect. So I can find mean, median, mode, all this data. Okay, then I can write in my descriptive summary like if the employee handled 44.17 calls every day. Every day, average, he is attending 44.17 calls. And the median and mean very close to each other. That means the employee has the uniform, reliable data over there. That means he is attending almost equal number of calls across 12 days. Okay, so that is a good thing, fairly balanced. So the range is 12 calls, and the standard deviation is very small. If you look at here, 3.63 standard deviation, it is a very reliable data you have for the particular employee. So in the sense, the employee performing consistently every day. So there are no obvious extreme values. So performance is very stable and consistent. So you can report like this for that particular employee. Maybe you can recommend him for promotion or increment or bonus. All good. Okay, friends, so far what we discuss is some basic measures that we use in analysis. Okay, so now let's move on to testing. The testing in the sense, why do we do testing is to ensure that our question is correct or wrong. Okay, so always what we do is, for before we take up analysis, we will have our own question, right? Our own research question, okay, or statistical question. Okay, for example, I'm telling, question here is, what are the health benefits of eating an apple a day? Okay, that is a question. So if you take apples every day, will your health be good, or will you not go to a doctor? Second question. So these are questions you can ask yourself. So based on the question, you can hypothesis. You can write hypothesis like, when we consume apple over 60 years, we can reduce the frequency of meeting the doctor. That is your hypothesis. So in the sense, I do not meet the doctor if I take apples every day. That is your hypothesis. So it could be right or wrong. Don't know. So what we do is we do the testing to identify whether our hypothesis is to be accepted or rejected. So what we do is we collect the data over a period of time. Okay. And then we check the data and do the testing and see that the significance. Okay. See the significance. For example, I'm telling, for the same question, what we can do is we can collect the data from 1,000 people. 1,000 people are the same age, same sex. Okay, same age, same sex. Just for example, I'm telling. Okay, over the period of time, maybe 60 days. Okay, and you record how many times. I mean, you record the visiting time, visiting to doctor for each person. So you have data. So the number one, attended or met the doctor on first day, 10th day, 20th day, 60th day. So you can find the average of meeting the doctor for that particular person. Same thing, second person, third person, like this you can do. Then you can find the average of the all data, whole population. Okay, that you can find out. Then with these things, the average and variance, you can do some testing. And you can see the significance. Is it the same for all people, or is there any outlier? That's what you are doing. You are seeing the significance of your collected data. When you notice that the significance of your data is related to the question that you have formed, hypothesis, you will decide whether to accept the hypothesis or reject the hypothesis. Okay, so the hypothesis is your idea of what you are trying to determine. It will be ideally related to some particular thing. Okay, maybe I give you another example. Which airlines have the most delay? That's the question. So you can hypothesize that the low cost airlines will have more delays. So that's your hypothesis. So you collect the data of different airlines across a period of time. Then you do the testing, and you ensure that low cost giving or low cost has more delays or not. Then you accept your hypothesis or you reject your hypothesis. Okay, hypothesis testing is the one we do after hypothesis written. After the question is formed, we do hypothesis testing. But sometimes the students may not understand this statistical analysis. Sometimes they find it very difficult. Okay, because of numbers involved. So it is better you understand the concept. You must know which hypothesis test is suitable for your question, because there are plenty of testing over there. We cannot just like that choose some testing. We choose the testing based on the question we have in our hypothesis. Okay, so it is better you choose the right test, follow the right procedure, then you do the interpretation. Exactly, you should have the justification of your claim, right? So you should do it properly to interpret your result and inform your management is correct or wrong. Okay, So what we do is always we write the hypothesis, which is called null hypothesis. Hypothesis testing is a process we used either to reject or retain null hypothesis. The null hypothesis is written like this: H naught. H1 is alternative hypothesis. So after forming your research question, you have to write null hypothesis and alternate hypothesis. For example, there is no need to meet the doctor when I take apple every day. That is your null hypothesis. Alternate would be there is a need to meet the doctor even if you take apple every day. That is alternate hypothesis. The next thing is you have to choose your right test. There are many tests I said right, t-test, chi-square, f-test, okay, ANOVA, many tests over there. So you have to choose the right test. Then after right test is chosen, you have to do some calculations to find out the test statistic. For example, if you are working with g-test, I'm just giving an example here, g-test in the sense. So once the hypotheses are fixed, I will find out G calculated. I will find out G calculated. If I am working with the t-test, I will calculate T calculated. So we have some formula to find out T calculated. So we find it first. All this formula will be using sample mean, population mean, sample variance or population variance. So depends on the formula that you have. It could be sometimes we use only 3 terms, sometimes we use 4 terms, like that. Okay, it depends on some formula. We find the test calculated or G calculated. Okay, whatever it is. Once you find the test statistic, what you do, you will compare your test statistic with the actual statistics value given by your table. Okay, that means we have some standard table, statistics table for each test. For G test, we have standard G table where you can find out G actual value. So this G actual you can take from your table. Okay, it's available already in the net, you can get it, or you can use Excel function to get it. Okay, but this G value we find based on alpha value. Alpha is referring to your confidence level, significance. That means you have to initially fix what confidence level you want to do your test. Okay, confidence level could be 90%, 95%, 99%. That means it could be 0.9 or 0.95 or 0.99. So based on this confidence level, your alpha is fixed. Your alpha is fixed. So this based on this alpha, we use another term called p value. P value will be 0.1 or 0.05 or 0.01 something. So based on this alpha, we choose p value. So if you are working with 90% confidence, your p value will be 0.1. If you are working with 95 confidence, your p value will be 0.05. Okay, so what we do is we take this Z value and p value from your statistics table. So you have to refer the table and take it. Then you go with the decision. So what we do, for the decision making, we see that our G calculated is within the range, less than the G actual, G statistics. So this is what we are doing. Okay, so we check whether it is greater or less than. How it is? Based on that, we choose, we reject our hypothesis or we accept our hypothesis, we retain our hypothesis. I'm just giving an example here. Look at here. This is your test value plus 0.96 minus 0.1, sorry, plus 1.96 minus 1.96. This is the t value for alpha equal to 0.05. For alpha equal to 0.05. Okay, it is a two-tail test. I will explain you one tail, two tail later. After some slides we have it. So whatever it is, then this is your reject area and this is your accept area. Accept area. That means when you are calculating your t calculated, if the t calculated value is less than this 1.96, your hypothesis, null hypothesis accepted. So you accept your claim. When this is not less than the value 1.96, then you will reject it. That means this is the reject area. So you find your t calculated. You see what it is. If t calculated is 2, then you reject it. You reject your hypothesis. That means your hypothesis is wrong. Your claim is wrong. Not good to proceed. So this is what we do in statistical analysis. All right. So now my question now is, do we need statistical test in machine learning? The answer is yes, sometimes we need. But I don't say we use statistical test always in our machine learning, because the priority in machine learning is different. But it is better to use statistical test in our machine learning as well. A strong machine learning study will often use both statistical reasoning and predictive validation. Okay, so what is statistical modeling? Statistical modeling is trying to find out the relationship between two groups. Okay, relationship or differences between two groups, and we try to find out the data that we have is statistically significant or not. Whereas the machine learning focus is more on predicting the value for unseen data. The focus is to predict the value for unseen data. But we can combine them together in our analysis, so that analysis will be better to explain, or it will be better to justify. Okay. So where statistical test is used in machine learning? Okay. For example, what you can do is, before you start modeling, before you start prediction model, what you need to do is you have to understand your data first. To understand the data, we have to do some descriptive statistics. Like you can go for t-test, ANOVA, chi-square test, or correlation. So these tests will give you clear idea of your data. You can understand your data. For example, if you have 10 futures, okay, with a response, a target. So you have independent variables and dependent variable. Okay, 9 independent variable, 1 dependent variable. So what you can do, you can correlate. You can see the correlation between this independent variable and dependent variable. That means you can see the how this independent variable is going to affect my target variable. You can understand. So you can explore the correlation between variables. Sometimes we do the correlation between independent variables. Okay, this is what called exploratory data analysis. We do this procedure. We follow this procedure EDA before we take a prediction model. Okay, actually, we are going to have the class in EDA later. Okay. So we do this kind of test before modeling. If you are working with the prediction modeling, particularly regressive models, then like linear regression is involved. if it is logistic regression, the regression model is involved. We use often p-values to assess the coefficients. So we in the regression model, there will be the coefficients b naught, beta naught plus beta 1x, beta naught, beta 1 are the coefficients which we assess from p-values. Next, you may compare two models. For instance, for your analysis, you are developing two different regression model, let us take, or two different classification model, let us take. Okay, for instance, you are doing random forest model as well as XGBoost model. You are collecting the performance of random forest and XGBoost. You may want to compare the performance of these two models. There the statistical test coming in. It is called a paired t-test. Okay, we compare classifiers. Okay, we check the assumptions. So we do this kind of analysis, statistical test in machine learning as well. For example, I just put an example here. Do Chand customers spend differently? That means the bank has customers. Okay, customers spending money. Okay, some customers they stop spending money. Okay, they disconnected themselves. Then after some time they are coming back for the transactions, churned customers, and they start spending money. Now the bank may be interested to see how the churn customers doing the transactions. Is the different from previous or same? So you have pre and post. You have two different groups, pre and post. These two groups of data can be compared. And you can do the analysis with this one and can see whether the customers spending more money after coming back, returning back, or spending less money after returning back. So this is a kind of test you can do in machine learning. Okay, in data analysis. Is subscription type associated with the churn? Is model B is better than model A? These are some examples of statistical tests used in machine learning. Okay, I just put here example here comparing two machine learning model. This is a random forest model. This is the XGBoost model. RMSE is the performance measure we use. Okay, we have many performance measure, R squared, RMSE. Okay, so what we do is we just list based on the fold we have. Fold in the sense it's all about. I will explain you later in the cross validation. So we consider one fold cross validation, two fold cross validation, or this is a kind of thing we do in the prediction model development. So what you can do is you can just find the performance of each model when one fold is used, two fold is used, five fold is used. So with this data, you can compare the groups. You can do the statistical analysis to compare and see which model performance is better. Okay. Then what is essential in machine learning, even without statistical test? Your machine learning needs your proper train test separation. That means if you have 100 data, you can use 70 data for training, 30 data for testing, or 80 data for training, 20 data for testing. That is more important. So the train test separation is important. Then next important thing is cross validation. This is most important thing in prediction model. Cross validation refers to, in case if you are using only 80 data to train your model, train your machine, that machine uses only the features of this 80 data, not this 20 data, right? So when you use this 20 data for testing, the performance may not be okay because of your machine has not learned the features of all 100 data. It learned the features only with the 80 data. This 20 data is missed out, left out. That's not correct way of working with. It may underestimate your your performance may be underestimated. So what you need to do is you have to accommodate this 20 as well in your training. So this is where the cross validation comes in. In cross validation, what we do is we choose randomly 80 data, train the machine. Then we use 20 data for testing. Then after this performance, we choose other set of 80 data. Other set of 80 data, not the same 80 data, other set of 80 data for training, other set of 20 data for testing. So this kind of iterative process, this is what called iterative process. We can do many number of times, choosing 80 data for training, 20 data for testing. This is what called cross validation. Here we have one-fold, two-fold, three-fold, five-fold, any number of times you can work with. So there are many ways to do this. Okay, there are different types of models, different types of algorithms we can use. So with this one, we can train the machine with all possibles, all possibles. So your machine may be very strong to predict your target variable for any unseen data. Sometimes when you are doing like this, it may go overfitting. Okay,